Hi, good afternoon, everybody. Let me know if you could hear me. We're going to begin shortly. So just say good afternoon once you can see my screen and you could hear my voice. All right, so the mission for today is to cover everything on the question number 6, so we could confidently be done with question number 6. And then tomorrow's class, we're going to go through an entire past paper from question 1 to 10 to kind of get you familiar with how to approach the exam question by question. Thursday, I would like us to finalize our formula sheet to make sure we have all the formulas for each question in one place so that you could start work on memorizing them, right? What was the next strategy? And I hope you guys are using your time to do the practice. Practice is almost even more important than what we do here online, okay? Because you have to see how fast you move, how slow you move, what are your strengths and what are your weaknesses, what are your strongest questions and what are your weakest questions, so that you can start working on that, okay? So we're gonna get started now where we left off. So this is just a case where we can just go through the steps and make sure you understand how to approach questions that look like this. And these are the 2 questions on the other slide. It's not moving. Yeah. So once we get through these questions, this would give us an idea of the types of questions that come for the exam, and we should be good to go. All right, so if you guys are ready, just say ready and we get started. Sure. All right, so let's get started. Now, keeping in mind, we already gone through the whole concept of the formulas, which I hope you guys start working on memorizing. Um, Yeah, so let's take a look at what we have here. So when you look at this diagram, again, we don't trust the diagram, so we make sure we read the details and understand what we're looking at, right? So it says the figure shows an open metal container. The cross section, and you should know the cross section means the face of the shape or the base of the shape is a semicircle. Keep it in mind, semicircle means half of circle. So that means everything we do would be around half of the circle, right? And it says the diameter of that semicircle is 2 meters and the length is 4.5. That means how long the overall shape is. What is the radius of the cross section? So this is the one I'm just going to go through quickly. If the diameter is 2, we know that the radius is half. So that means the radius is 1 meters long. Let's just go quickly and make sure everybody with me. Everybody understand that one? Everybody got it? Radius is half of a diameter. So you just have to divide by 2 or half it, right? Next one. calculate in m square, meter square. So that means we got to pay attention. Always pay attention. So the units they gave us is in meters, and the answer that they want for us to have is in meters as well. So we don't have to do any conversion. Always back check that first. Two decimal places. So that means we have to round off our answer. So the first thing they want us to find is the area of the cross section. So let's go back to what a cross section is. The cross section is a semicircle. So we can't just directly calculate the semicircle. What we always have to do first is find the area of the overall circle and then divide by 2. So here they have pi r square. Let me just zoom in. Can y'all see? Or it's looking a little bad. Can y'all understand? Y'all seen it, right? All I want to do is just go through the working so that you understand and we can move through faster. So as I was saying, they want us to find the area of the cross section, and the cross section is half of a circle. So they're going to find half of the area of a circle, which is pi r square. And here they use 22/7, but it is okay to also use 3.142. So it doesn't matter. We calculated r above, so we know r is 1. So that's where you would have 3.142 times 1 times 1, which is r squared. And so that's your answer. Pretty easy. Everybody okay? Don't forget, whatever answer you got here, you had to half it to get your answer at the end. Next one, the outer curved surface area. Do you know what they're talking about when they say the outer curved surface area? What do you think they mean? All of these, yes or no? Do you know what part they're talking about when they speak about the outer curved surface area? I see 3 people answer. I'm watching the chat. Talk to me if you understand what they're asking for. What they're talking about, right, is you see this area shaded gray here? So for example, let's say I drew, let me try to draw it. But remember, this is a whole cylinder. What they're talking about is this area here, because remember this area curved. Remember, it is curved around like that, right? Everybody see what I mean now? So almost like all of this piece underneath here, go all the way inside here. Now, listen to this joke, right? When I open up this section, what shape is supposed to have? Because we spoke about this yesterday. When you cut a cylinder open and you spread it out, what shape is it actually when it's not curved? Is that true? Is it a rectangle? Is the same 4 people responding to my messages and my questions? So that means only 4 people should stay inside the class then. All right, let me start removing people, because it makes no sense for people to be here if they're not going to respond and participate, right? So let's start. And if I remove you from class, you're not going to be able to join back. So that's my first warning. All right. So as we said, it's going to be a rectangle. Now, we know the rectangle to find the area, because remember the ask for the area, right? Is length times width. One number going to give us the length and the width. Which one is the easier one to find out? What number is the length of the shape of that rectangle? Excellent. Very good. Very good. But is the width easy to find? Is the width easy to find? Why is the width not easy to find? Because we know that the width is this here. But when we open it out, it's going to be longer, and it's right or wrong? Everybody see, this is a very important concept. I hope everybody understand what's going on. Remember, the width is this, but it curved. So even though when we open it out, it's straight right now, it's curved. What this line represents for the circle? What do we call this line? What is this distance around? What is this length called? Is the C word. What is it called? Excellent. Everybody agree? So to be honest, the width is actually the circumference of the circle, but it's not the whole circumference. Instead of the whole circumference, it's going to be what? Half of the circumference. So I need everybody to tell me if they understand that part. So we know the length is easy. The length is just how long it is, 4.5. But the width is the circumference, because after we open it out, that is what can give us the straight line. So do we know how to find the circumference of a circle? So everybody see here, look at it. You see what it did? Circumference times length, because the shape is a rectangle. So you're going to be length times width. But because it's half, it's not the whole circumference we use, and right or wrong, it's not the whole circumference we use. We only use half, and that's why they half it. So all I need to know is if everybody understand how we use the circumference to find the shape or the area of the rectangle. So if you got it, say got it. Because everything else is easy, right? You just plug in the formula or watch in the chat. Because if I see a question like this, I should feel good that, okay, we understand that, we're good to go. All right, now let's move on. The last one says the total outer area of the container. What is another way of saying the outer area? This ain't the exact same way of saying the total surface area. I mean, just the area of all the surfaces. So what do we need to find? We already find the face. Do we need to go find the face for the back again? No, because the face and the back is the same thing. Do you agree? So you just got to find the cross section, which we did earlier, and then multiply this by 1. Multiply it by 2. And then what do we add? We add the area of the curved surface, and we literally just find that above. So all you have to do is add it. Everybody see what's going on here? Let me just show you the relationship. So 2 times the semicircles, which is what I did here, 2 times the semicircles plus the curved area. That's how you get the total surface of that shape. So let's see which questions we did so far quickly. We did this, we did that, we did that. All right, let's move on to the next one. The capacity. Anybody could tell me what's another word for capacity? CXC does use this word sometimes. So you got to make sure you know what it means. What does the word capacity mean? Another word for capacity. It's the V word. Yes, so the word capacity also means volume. So please write this down in your book. They're the same thing. Volume means capacity. Capacity means volume, right? And they want it in meters cube. Now, why is this easy? Because all of the units are already in meters. In the exam, you don't ever assume it is the same. Always check. Make sure if everything talking about meters, everything using meters. Make sure it's not centimeters or millimeters or even kilometers. So what do we know about volume? How do we find the volume? Volume is always equal to the area of the cross section times the height. And in this case, we know what number represents the height. What number represents the height? The length, which is 4.5. We already found the area of the face. What was the area of the face? 1.57. So look at here. Everybody see? Volume is equal to the cross section times length, which is the same thing as the cross section times the height. Volume is always the same thing. Area of the cross section times the height or the length of the shape, right? Everybody okay so far? Everybody okay and following? I want to make sure that when we go through these questions, you realize the patterns that you're seeing, that the patterns keep coming back. It's literally almost the same thing we're doing back to back, just in different ways, okay? So that's how you find the volume. And then what's this part, no, oh my God. D, this is the part I want us to take our time and go through. You see these last two? These is where CXC does do this a lot. So let's go. Everybody pay attention. Let's focus. So we done got the answer for the volume for the entire container. Water is poured into the container at a rate of 40 liters per minute. Anybody realize what's going on here? You realize we've been measuring volume all along, but what units of volume we were using before? We were using meters cube. Everybody agree? Now, all of a sudden, the question asking for liters. That's the first thing we need to understand. Everybody realize that? So you know what's gonna happen, right? At some point, you gotta change one into the other. Everybody with me? So look at this. They're saying water is poured at a container at a rate. So let me show you how to calculate your formula. So check this out. Rate. So that means rate is equal to liters per minute. I taught you how to figure out the formula. What does the word per mean? What operation does per mean? Because we did this in a class online already. Per means to do something. Mm-mm. When you're doing something per person, that ain't me. You're doing it for everybody. So you gotta divide it up for everybody. Everybody with me? So rate is equal to liters divided by minutes. So that's the formula there. Just from the units, you can get the formula. So liters divided by minutes. So let's make sure we're on the same page about that. So just from this sentence, we generate our formula, how to calculate rate. Yeah? All right. So check this out now. Look at what it did. They first identified that 1 meter cube is 1,000 liters. Please write this down in your books. You need to memorize this. This is very important. They're always doing this. They're always going between meters cube, centimeters cube, and liters. So let me write this down. 1 meter cube is equal to 1,000 liters. Something else that you need to know is 1 centimeter cube is equal to 1 milliliter. Copy that down, please. These two conversions you must know out your head. When you're finished, sit down. Guys, hold on for a minute. Please hold on for a minute. Again, a call, an important call. Hey guys, you can hear me now? Okay, I just want to share some good news for you guys. Um, I just got a big job for music festival and White Sands and an event at Park Hyatt. So yeah, I just feel very happy. Um, so just letting y'all know too, sometimes when we don't have sessions on Sunday is because I work, okay? So just a heads up, but that's why I want us to make use of as much classes as possible as now, because I don't know how my schedule would be closer to May, because May gonna be really busy for me, okay? So let's try to do as much as we can in April. So at least May, all you should be doing is doing your own revisions, right? Thank you guys. All right, so let's go, guys. Where were we? Where we reach? Where we reach? I think I was showing y'all the formulas, right? Thank you guys. I feel so happy. Okay, yes. So let's make sure one, everybody understand how to do the formula. So let's do our next example. Suppose I say speed, I say speed, right? Somebody going at a certain speed and they're going at 100 miles per hour. Do you know the formula from this? We know per means divide, right? So that means that the formula for this is miles divided by hour. And if you think about it, what does miles represent? Miles represent distance divided by time. Everybody see what's going on? So speed has a formula of distance divided by time. So anytime they give you a unit of something they're talking about, look at what the unit says, because they're going to tell you how to calculate it. If you got it, say got it, because I don't want to continue unless everybody understand how to generate the formulas on their own. And if you notice, CXC doing a lot of this recently. So once you see per means to divide. So I'm going to say it again. I just told you that somebody was going 100 miles per hour. How do you calculate your formula for speed? Per means to divide, right? Don't forget, per always means to divide. So what are we dividing? We divide in miles divided by hour. That's what I did here. Miles divided by hour. And if you check it, miles, we don't measure distance in miles. So that's distance, how fast somebody goes. So it's distance divided by time. Why time? Because hour is a measurement of time. So if somebody had given you minutes, could I use minutes? I can't use minutes, because what does the formula use? The formula use hours. So I would have had to then change minutes into what? Hours. That's the most important part. Understanding what to use, how to use it. Leon, that's a little better. You understand it a little better? All right, so let's get back here. Let's get back here. Yes, get back here. All right. So water is poured to a container at a rate. So that means the answer is rate of 40 liters per minute. So that means every minute you get 40 liters. That's what it's saying. Every minute is 40. So 40 is equal to liters, every 40 liters per minute. Okay. So let's look at what they ask us to find now. Because this ain't a question, this is just information. Oh, I realize that, right? So that even though they said DE, this wasn't asking us anything. They just tell us that that's how much it takes. So it says, how long would it take to fill the container? First thing first, what information we have out of the formula? Don't we have the rate? So let's substitute. Let's do this together. The rate don't change. If it's one thing that don't change is the rate. No matter what, the rate stays the same. So we know 40 is equal to, which one do we have already? Do we have the minutes? No, that means it's the minutes that we want. How long? The time. Do we have the volume? Do we have the volume of the shape? That ain't what we calculated earlier. Talk to me, the capacity of the container in the volume. But look at this. The volume we calculated was 7.07 meters cubed. Can I use this in the formula? This is an important concept we're talking about now, because this is what you have to realize in the exam. Even though you have the volume, you do not have the volume in the correct unit. You need it in liters. So what does that mean? That we have to change what? Meters cube into liters. How do we do that? 1 meters cube is 1,000. Anybody could tell me if we should multiply or divide by 1,000 to change it? Everybody. We got 21 people here. I need everybody to tell me which one we should do. Multiply or divide to change from meters cube to liters. I'll watch in the chat. I'm watching the chat. I'm watching the chat. There's a reason I'm asking these questions, because I want to know what you would do in the exam so that I could explain. Okay. Thank you very much for those who are responding. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Okay. Here's a trick, guys. The answer is multiply. Here's how you determine that. Look at the quantity. You're moving from a 1 digit to 1,000 digits. Everybody see what's going on? Which one of those between multiplication and division would allow you to do an increase? Everybody see what's going on? Anytime your answer is bigger, let me say generally, because you got some exceptions, you always got exceptions, but this is generally. Anytime your digit is moving from smaller to bigger, it must be a multiplication process, especially when it comes to converting. You want to change one unit to another, look at what happens to the digit. That is what I'm going to tell you whether to multiply or divide. Everybody with me now? So you want me to do another one? What part you can't see, Janesco? You can't see the screen in general? Josette? Or you're just catching up, you mean? So that's why it's a little confusing. So as I was saying, guys, okay, no problem. So we got to take this number and multiply it by 1,000 to change it. Everybody see why they did it here now? To change it to liters, you multiply by 1,000. And this is the number that you use, right? So now let's substitute. So we got 4,000. Sorry, here we go, 4,000. Sorry. So we have 7,070 over. What letter we just put for something we want to find out in X? So we put X here, right? Now, what are we trying to find? Anybody could tell me what we're going to do here? Are we going to multiply to transpose or switch? And for those people who remember classes, even online, you should know when you should do the other ones, which one you should use. How do I find X? How do I transpose to find X? Do I multiply or switch? And this is a question for every single body. You should know how to transpose, because this is algebra. This is algebra. Excellent job, everybody. For those who don't know why switch, whenever the thing that you want is in the denominator, you got to switch it. Yeah? If X was in the numerator, so let's say X was in the numerator. Sorry. Correct. Very good. Very good. Everybody see the difference? Let me make sure you understand. If I wanted X here, that means I need to get rid of, oh, my battery dead. Hold on. If I wanted X here, I would have to get rid of divided by 7,070. So that is why I would multiply, because multiplication is the opposite of division. You multiply by that number, and what it's going to do is cancel it, giving you X. But when the thing that you want, which is x, is in the denominator, you can't just multiply by x because then that will cancel it out. That's not what you're trying to do. You're trying to find x. So you switch. So wherever x is, x gonna go here, and 40 gonna go below there. And that's how you work it out. So everybody see they didn't show us the steps, but they have the same working. And your answer is going to be in minutes. And then how did they ask for their answer? Make sure you always back check. They say they want the answer to 2 decimal places. Okay, guys, give me 1 more minute again. Sorry about that. So back to it. So guess what? That's it. Now that we went through it step by step, let's discuss it. Let's break down each step. Everybody understand how we got from one step to the next? So when you look at it piece by piece, it's not that difficult. What you have to do is pay attention to the details and what they're asking you for. So if you was to rate this of a difficulty out of 10, 10 being very, very hard, 1 being super, super easy, what would you rate this based on what you know and understand? At least everybody could do this. Rate the difficulty level, because what I'm going to do too is look for some past paper exams to kind of reflect questions that y'all tell me that you think is really hard. Okay, 5 not bad. Okay, 7. 7 is the hardest score so far, the highest score, I think. I think somebody said 8, a difficulty level of 8. 6, okay. All right. Let's move on. So long. I'm watching the chat still. Let me just erase this work in here so we could start fresh. All right, if you're ready for the next question, let's go. This one is CXC. This concept is a very popular testing concept. Containers with water of a certain height and how much more water it needs, or how much more water it needs to be emptied out. So once you're ready, just say ready and we get started. 24 people, there we go. All right, let's get it going. Let's get it going. Remember, the mission is no punk fights. We're going to try every single question. So what we're doing is expanding our mind to be prepared to do as much as possible. So let's look at this question. They say water flows through a pipe at a rate. Okay, check this out now. You see the word rate come again? This is a measurement question, you see? The people are just trying to stress out. So a rate of 1,250, let me zoom in here, centimeters cubed divided by S. What do you think S stands for? Somebody, what S stands for? Remember, rate tells you how fast something is happening, right? Generally, rates tell you how fast something is coming. So when you think about what we did before, let's go back. Let's go back. Here, our rate was per minute. Think about it, per minute. This rate was liters per minute. So if you gone over here, what you think per, what time unit would S represent? You see, I just ask these questions so we could think, choose one, which one? If somebody say how fast something happened, yes, that's speed. But in terms of how do you measure how fast something happens? In time. So which time starts with a S? Everybody realize this is the same question, it's just that you're using different units. Before, we had meters cube per minute. It was meters? Hold on, it was liters, sorry. It was liters per minute. Now, what are they giving us? They're giving us now centimeters cube per second. So somebody tell me what's the formula for this, for rate here again. So rate has a formula of what? What does centimeters cube represent in volume? Volume divided by what? What does second represent? Time. Keep it in mind, volume must be in centimeters cube and time must be in seconds. So everybody see how we just created the formula again from scratch, just from the sentence? I hope everybody okay with that, because it's the same thing, just different units now. You see the patterns, what we spoke about before? Same types of questions continuously come. How long will it take to fill up a tank of length 1 meters width, 1 meters, length 1 meter, sorry, width 1 meters, and height 1.5 meters? So let's look at this. What information we have from this sentence here? Don't we have R? Because R is the rate. Label the information. Look at what you have. Do you agree? So out of the three of them, we have R, which is the rate. What else do we have? What they ask us to find, how long. So if they're asking how long, which one of these here they're asking us for? The time or the volume? That means they gave us a way to find volume. Do you agree? They ain't give us everything we need to find for our volume. This ain't a cuboid. So what did they give us? They gave us the length, the width, and the height. And everybody know the volume of a cuboid is just what? Length times width times height. So you have to calculate your own volume this time. So let's go over here and make sure we understand. Also pay attention to the units. What are these units? This is meters. But what does the formula need? Anybody check that going on now too? The formula uses centimeters cube, but the question gave us meters. So you should know, one, calculate the volume, but you got to change all of this to what? You got to change it to centimeters. Yeah? I hope y'all with me now. All right, so let's take a look at how to do so. This is a harder way. So let's find the volume first. So they gave us 1 meters for the length, 1 meter for the, is 1 meters they give us? Yeah. It's 1 meter. Yeah. And then they gave us 1.5 for the height. Sorry. This is length, this is width, and this is height. But what are we looking for in centimeters cube? No, I don't like how they work out this because this is going to be harder for you to understand. So let's do it yourself, right? How do I change meters to centimeters? Somebody. I did a conversion cloud yesterday. Millimeters, centimeters, meters, kilometers. Did y'all copy down the conversion cloud? Not by 10. No time. From kilometers is 1,000. From meters to centimeters is 100. From centimeters to millimeters is times 10. Please copy this down if you ain't got it. And the opposite direction is division. Divide by 10, divide by 100, divided by 1,000. All right, y'all ready? So we work it out the better way, the easier way. So I just got to multiply this by 100. You still writing? All right, so let's go. So that means this would be what? 100 centimeters. 100 centimeters. 150, sorry, 150 centimeters. So now it's all in centimeters. I could find my volume. So somebody with a calculator, 100 times 100. Actually, you don't even need a calculator, to be honest. So let's start off with 150, right? How much zeros should I add on, everybody? Let me see who's thinking. So we started off with this part here. How many zeros should I add on to 150? Y'all not listening to the question. I didn't ask how much zeros in all. I said how much zeros I should add on. Come on. How much hundreds I got here in? 200s? So how much zeros in all? See the difference? It's 4 zeros, right? And let me make sure you understand how it's 4 zeros. Look at the 200s. The first 100. Sorry, my pen have a short. Okay, as I was saying, this 100 would give me 2 zeros around that. And this 100 would give me 2 zeros. So in all, I added on 4 zeros. Everybody with me now? So the answer would be this amount in centimeters cubed. So just like that, that's the answer. What they did here, though, is that they represented this number as, what we call this again? When you got times 10 to a power, what do we call this in number theory? Something notation. Anybody remember scientific notation or standard form, right? You should be able to write any number, and I'm going to just do it just to remind you how to do that. You should start with the point in the back. So let's jump because we only want one number in front of the point. So we're going 1, 2, 3, 4, 5, 6. So this is where the point gonna end up. So our answer is 1.5 times 10. How much powers we jump? 6 times. And because the number is bigger than 1, it's gonna be a positive 6 centimeters cubed. So let we go. Everybody understand now? Right? Small revision, right? Small revision. So that's how they got this number. It's the same exact process. All right. So let's go. Let's go, let's go, let's go, let's go. So now that we have our information, we just got to substitute it now into the formula. So like I said, we have the rate. What was the rate? Let's substitute it. The rate was this number, 1250 is equal to volume. We just work out the volume. 1, 5. How much zeros we had again? 5, 6? 1, 2, 3, 4, 5 zeros. Okay, I doing it the long way and the easier way because a lot of people may not understand it the short. 1, 2, 3, 4, 5. And because we're looking for time, what do we use to represent time? We use X, right? Again, X is where in the denominator. So for us to calculate Oh, sorry about that. Let me just carry it back. You seen it? You're welcome. So here now, all we gotta do is switch, right? So when we switch, X gonna go here. So this is what is this here. Everybody see how they got it? That's what this means. So the long number divided by, because you switch these two, and that's how they're gonna give you your answer. But your answer is going to be in seconds. If you leave your answer in seconds, it's still right. Anybody know how to change seconds into minutes? Let me just ask quick in general. How do you change seconds into minutes? Not because me teach you. You think about time. How many seconds in a minute? So how do you determine how much seconds would give you, how much minutes given by 1/22? You have to divide by 60 to change seconds into minutes. Look at the value. Look at the value. That means y'all ain't remembering the things I teach you. What is happening to the values of the digits? The digits ain't getting smaller. Right or wrong? So it could never be multiply. It must be what? Divide. Everybody with me? So let's just pause here and make sure you're with me so far. Check in, check in, check in, check in. All I'm doing is making sure you understand how to process these questions. Okay, let's move on. Last part of this question say, what? Oh my God. What is the height of the water in the tank after 12 minutes? No. Some people be like, I don't even know where to start. When you're doing a question in maths, what do you always start with? In the formula? No problem. So let's start with the formula. Rate is equal to volume over time. No, they didn't ask us for volume. They didn't ask us for time. They didn't ask us for rate. They asked us for height. Which one of these here got height inside? That's a very serious question. We can't get height directly, but one of these here have something that could give us height. Which one of these here got in height? Can I say volume? Is that true? Because on the side, keep in mind, volume is equal to length times width times height. So what CXC expects you to realize is that the first thing you're gonna have to do is use the formula to find the volume. So let's go. What information they gave us? They gave us the rate, because the rate never changes, 1250. They didn't give us the time. They didn't give us the volume. That's what we want. So we're gonna call that X. They didn't give us the time. Time is 12 minutes. But that ain't sound familiar. How do we change? Do we use 12? Should I put 12 on it here? That's a serious question. Should I just put 12 on it here? Everybody, let's go. Yes or no? Do I just put 12 on it here? Is all I got to change it to? I have to change it to something, but what is it I have to change it into? Look back upstairs here. What's the formula over? Time supposed to be in what? Thank you. Time's supposed to be in seconds. So we need to change 12 minutes into 12 seconds. So that's okay. That's why we're here. We're learning. How do I change minutes into seconds? Just like how we did the division is the opposite your times. So you're going to go and you're going to say 12 times 60. And that is what's going to tell you how much. How do I do this without a calculator? 12 times 6 is 72. And then you add the extra 0, 720. So 720 seconds. So people, how do I work out X? Do I switch or do I multiply? Excellent. You multiply by 720. So that's how you're going to get. Somebody check this for me to make sure that's true. Multiply. So X is equal to 1250 times 720. Somebody multiply that for me, please. Tell me where you go. Let's back check it to make sure it's right. Yep. Anybody else? Thank you. So that means our volume, and then our volume going to be in centimeters cubed is going to be this. And we're going to change it back into meters by just dividing by the same thing we did up here. Divided by 6 jumps. We jump it by 6. So let's see what we get if we jump it by 6. 1, 2, 3, 4, 5, 6. Anybody remember why I jump in by 6 again? Where did I get 6 from? That ain't the same thing we did up here when we was jumping. Everybody see that? To move it forward, we jump by 6. To move it backwards, you jump by 6. That's all. Same exact thing. So now we know that we could calculate the height by that because we know volume is equal to area times height. So to find height, we just divide by area on both sides. So height is equal to volume divided by area. That's just transposing. And that's how we get our answer. That's it. Was this one harder or easier than the last one? One person say harder because you got to start looking and seeing which one. Okay, somebody else said easier. Harder. Come on, talk to me, people. 25 of you in here. Was this question harder or easier than the previous question? Okay. Waiting for more feedback because I want to know if I should do more questions with volume compared to questions with rates, like what we did before. So we have a mixed review because half saying easy and half saying harder. All right, let's look at this question. We did a question like this before, innit? We didn't do a question just like this. We didn't do one like this already. When we had to find the area of the triangle and then subtract it to find the segment. I'm not going back over this because we killed that last night. I'm going to go to the cylinder question. Let's do the cylinder question and then the cube. This one here, oh my God. This one here, we got to do for sure. The cone, we got to do the cone question. All right. This one look a little easier. So let's look at it and see what's going on. How many buckets of, oh my God. You see they start with the buckets thing, but that's okay. We could do this. How many buckets of volume? So that means, first of all, you gotta understand, right? One bucket is 10.5 liters. Please do not be afraid to mark up your exam. Write it out in a way that makes the information easier to remember. So how many buckets of volume? That means one bucket is 10.5 liters, right? Can be filled from a cylindrical tank of volume 1.5 meters cubed. Anybody realize what makes this question hard? Let me see if you are really focusing and paying attention. This question ain't hard, but something made it a little challenging. What is the thing that makes this question a little harder? Not the percentage. Try again. Look at the information. What about that information is a bit, makes it harder? One part give you information in liters, and the other part give you the information in meters cube. Everybody see that? So what is the conversion again? Because remember, you gotta memorize that, you know. How do I change 1 meters cube is equal to how many liters? Because you got to memorize that. And if you leave class today not doing this, that means you ain't learn nothing at all. So talk to me. How many meters cube, liters give me 1 meters cube? 1,000. You have to know this out your head. That's one thing you must know. All right, so that's what we're going to start off with. The next thing we need to know is, oh my God, 1.5 represents what? 1.5 represents how much water in there, or the total volume of the tank? That's the next question for somebody to try. Does 1.5 represent the entire tank or the water in the tank? This is the reading part we talk about, and I need more people to respond. Me asking you to work out nothing, me asking you to train, I just asking you to tell me what you understand from the sentence. What information does 1.5 represent? Does it represent the volume of the tank or the volume of the water in the tank? So I seen 4 people say the water. I'm waiting for 22 other people to say something. Another person say water in the tank. Somebody said the tank. Watching. I just want to see, because then this is where we develop our reading comprehension, which is literally one of the most important skills in the exam. Guys, the answer is the tank. They say that the water is 75% full with water. The tank is 1.5. Can be filled from a cylindrical tank of volume 1.5 if the tank is 75% full with water. For those who said the water, you see the difference? The tank is 1.5 meters, but the water is 75% of the tank. Okay, so be very careful when you're reading. What is this asking us for? Oh, how much buckets? Okay. So the next question I got asked, do anybody know how to start this? I don't want to just tell you. Let's see if you could figure out how you will go about answering a question like this by yourself. Do you have an idea of how to start this? All I need is yes or no, and they're going to take it from there. Okay, somebody said find the volume first. Okay. Janella said yes. Yes, somewhat. Okay. Set out a formula. Okay. I just want to see how you would deal with a question like this. Somebody said not sure. That's fine. All right. Let's take a look at the question. Let's list out all the information. Excellent. So I done list out one thing already. The first thing I list out is that 1 bucket is 10.5 liters. What other information I have? I have that the tank is 1.5 meters cube. And then I have the water is equal to 75% of the tank. But what is that? What is the tank? The tank is 1.5 meters cube. So I have the 3 pieces of information I need. What do I notice about all 3? All of them in different units. One is a percent, one in meters cube, one in liters. So we need to have all of them in the same thing, right or wrong? So the first thing I would do, I wouldn't change the meters cubed to the liters. I would change the meters cubed to liters. And we know how to do that. We know all we got to do is multiply, because we're going from smaller to bigger, by 1,000. So I would take my 1.5 times 1,000. That means I jump my point 3 times. So 1.5, jump it 3 times. 1, 2, 3. I add zeros here. So that means my answer is 1500 meters cubed. So now I realize I have, sorry, hear me about meters cubed, liters. Sorry, that's liters because we just changed it to liters, right? So that means that I now have how much volume in the tank. So I could put here the correct conversion. So now I got this in liters as well. 1500 liters. Who else I need to change? In the water. Do we know how to find 75% of something? You should remember 75% means 75 out of 100. The word of means to multiply, and we just find how much the tank is, and the tank is 1500. So put this over 1. If you use your calculator, all you have to type in 75 divided by 100 times this number here. If you're doing it the long way, this is what you would do. You will cancel your zeros. So all you're going to end up with is 75 times 15. Somebody please, what is that? So 1125 liters. So how do I go from here now? Now I have all of my things in the same unit, so now I could work it out, right? One bucket is 10.5 liters, and there is 1125 liters. How do I determine how much buckets could go? Somebody tell me what I should do. Should I add? Should I subtract? Should I multiply, or should I divide? Which two numbers is the most important numbers? Ain't just the bucket and the water. So one bucket is 10.5 liters. And the water is 1125 liters. What am I going to do with these two numbers? How do I determine how much buckets I get from the water? Before you say multiply them, think about it. You're trying to find out if you got a basin of water, and you, like, I don't know, water, let's go here, right? You going to bathe in a bucket, you got a cup. How you just determine how much cups you need to bathe with? You ain't scooping out water. That mean you're taking out water. So what that means? That means you could be doing what? And dividing. You're dividing the water into each cup. You're subtracting each time, but overall, you're splitting up the water by the number of cups you have, right or wrong? So you understand how you should be thinking, Jay? So somebody do that for me. How much that gonna give us? How much buckets that? So 1125 divided by 10.5. How much is that? Remember, you can't have point something of a bucket, eh? Think about it. You can't have a piece of a bucket. So what does that mean to you? That you must do what? Round it off, right? But anybody realize what the most important concept here is? What is the most important concept? That you have to convert units to match each other. Everybody with me? You realize that's the most important thing, right? Everything else is really critical thinking. You must be able to identify when to multiply and when to divide. And you need to put yourself in the situation. So if you're reading it and you ain't really sure, think about it. Take a situation that looks similar. You don't have to divide to find out how much buckets. But then if you're going to catch or full up something, for you to determine how much buckets you need, you got to split up the water in a certain amount to fit in each bucket. All right. So how was that question? Easy or harder? Let's go. And everybody's seen the patterns when it comes to the conversions. I hope y'all seen the patterns in the questions. That's really important for me, for you guys to leave with, that you understand what to expect in how the questions come, what you generally have to look out for, and what you have to do. All right, this one is the hardest one out of all. Jesus. Just look at this picture here, first of all. This already confusing, no? The way it look. So I think what I did here was I rewrote these numbers so you could see it better, because you realize they're kind of blurry. So those numbers are the numbers that's supposed to be there. But what I check in is, yeah, I think so. So let's go through this question. I think this is the last one, and then we're going to look at some exam questions. Yeah, this is the last one. And then I got some formulas I need y'all to write down for me. So let me just do the formulas so that when we finish, we just go straight to the exam questions. We already know. Okay, you know what? I like this question. Look at this. Anybody remember last night when we were talking about how to find the shaded areas? When you're trying to find a shaded area, what is always the approach? A, find the big shape first and minus the small shape that's missing. This concept is the same thing like what we were doing last night with the shaded area. So I want you to see the formula here. Volume of the tank, which is the shaded area, is equal to the volume of the large cone minus the volume of the small cone. Look at it. That ain't exactly what we was doing last night, just with a different shape. Originally, one was two squares, one was some other shape and another shape, but it's the same thing. You want to know what this shaded area is, find the area of the overall thing, find the area of what it took out, and obviously what it took out was the smaller cone. And what does took out mean? To subtract. So this concept is extremely important. Volume of large cone minus volume of small cone. To be honest, it's all about formulas here. You don't know how to find the volume of a cone because I gave it to you last night. All those formulas were given last night. So you just substitute into the formulas and calculate it. All right, get your books ready. You're going to copy down these formulas for me. So these are important. Duration, they just give questions like this. Oh, you leave a train station at this time. You arrived at this time. How long was the trip? So that's the first formula you're going to have when it comes to time. Duration is equal to arrival time minus departure time. When you're done, sit down. That's two persons done. Come on, talk to me. I need to know if we could move on. All right, next formula. Now, this one is the one that's most important, and we're going to discuss the second one. And let's make sure we understand what each letter represents here. So here it says, you're going to write down speed and distance. So in this case, speed, we kind of did it before, is equal to distance over time. Now, the thing is about speed. Speed could be measured in kilometers per second, meters per minute. The distance could change, the time could change, but it's always going to be distance over time. Some people do kilometers per hour. It doesn't matter. So it could look like this, kilometers per hour. Sorry. Per hour. And y'all know that this slash means divide two, right? this slash also means per. So these are the different ways this could come. Kilometers per hour. All of these things is the same exact thing. When you finish, copy that down. Also, let me know and say done. These are the conversion formulas that you need to know. These are the ones that come a lot. Okay. No, I believe in having all the information, right? So what this does is it tells us how to calculate a mile, how to change a mile to kilometers. So just copy this down. What does this mean? 8/5. What does that mean? We could represent this number by using a decimal. So somebody tell me, how do I change 8/5 to a decimal? These are things you should know how to do as well. Anybody? What does 8/5 mean? Remember, 8/5 just means, this means 8 divided by 5. So somebody put 8 divided by 5 in your calculator and tell me what I mean. So that we know 1 mile is equal to a decimal. What is that decimal? 1.6 kilometers. So copy that down as well. All right, so that's it. So guess what we're going into now? We're going into the past papers. Question number 6. All right. Let me know if you are ready. What we're going to try to do is at least do January and June. We have a half an hour. So let's see how much we could get done, okay? All we're going to do is read through the question and make sure we understand what we're looking at. Okay, that's what we're focusing on. So if you see something, you shouldn't feel panicked. You should be able to read it and understand what you're looking at. All right. 2 persons said already. That's it. Anybody else? Are you ready? Let's go. We got this. We got to stay motivated. We got to stay. I hope y'all using our time wisely. If you was wasting your time on before this is when you're supposed to start getting serious. So, yeah, let's go. So, first thing we see here in this diagram, using pi 22/7. So you see, this is basically telling us that CXC want us to use this version of pi and not the decimal. Keep in mind, if you realize you try to use the fraction and ain't working out, please to use the decimal and get an answer. They got to mark it. You're not going to get full marks, but you're going to get a mark rather than getting 0. Okay? All right. The diagrams below show a hemispherical bowl. Lord Jesus, help me. And a cylindrical tin. What does this mean? Anybody know what's a hemispherical bowl? That means it's like a ball, a 3D shaped ball, but it's half of it. Everybody with me? Don't let these words fool you. Don't let it stress you out. So far we have a sphere. We got half of a sphere. So let me just write it down. We got half of a sphere. And didn't we done do the formula for a sphere already? I gave y'all the formula for the area and volume of a sphere, which you have to memorize. If you don't know it, I can't help you. And then we have a cylinder, which look pretty straightforward. The diameter of the cylindrical tin is 12. Always make sure that the data in the sentence is already in the picture. If it's not in the picture, you add it in. Here we see it's already in the picture, straight across. Quick question for everybody. What would be the radius of the cylinder? What is the radius? If the diameter is 12, what's the radius? Excellent. That's what I like to see. We ready? We thinking. Good. The height is 17. Make sure you're seeing it. It's there. And the radius of the bowl is R. So they did not give us the radius of the bowl for the hemisphere. Okay, so let's continue. It don't seem too intimidating. So let's see what's going on with the first question. Show that the volume of the cylindrical tin is this answer correct to two significant figures. I don't know if anybody remember this, but from my class, you remember I keep telling you that's how questions gonna come. They're gonna give you the answer and ask you to prove that that's the answer. This is a perfect example. Everybody with me? Hello? Good. Now let's go back up to see what's going on. You realize, right? What they're trying to say is that both of these shapes have the same R. Anybody realize that? So if we know the diameter of this shape is 12, that means R is 6, which is what we agreed to earlier. So this is really easy. Again, all we gotta do is find the volume of the cylindrical tin. I gave you the formula for volume already. If you don't have it, this is it here. The volume of a cylinder is pi r square h. And you should know why. Area of the circle times the height. And what is the area of a circle? Pi r square. Everybody with me? Just let me know if you're with me so long, please. That's all I need to know. Even if, yeah, just let me know if you're following. All of this we did already. Because to be honest, no way watching questions like this, it's kind of easy to me. So let's go. So we know that pi, they tell us to use pi as a fraction, 22/7 times r. And I don't know why CXC do this, but they could have just put 6 in my mind. So let's go over here. 22/7 times 12 divided by 2 is 6. So 6 square times 17. And everybody know why they use 17, right? Because 17 is the height of the shape. So people get your calculators and make sure you can get an answer. That's all I need. Get your calculators and make sure you can work out this question and get the same answer. No, 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 no. If you were to type this in your calculator, how would you type this in? You should know that this means 22 divided by 7. Oh my God, sorry about that. This just means 22 divided by 7 times 6 square. And 6 square is really what? 36 times 17. If you get the answer when you type it in, say got it. Please make sure you're checking your please make sure because remember it's just you and your calculator and the exam paper. Make sure you know how to get your answers. It's very important. It's very important. So this one was really easy to me. I hope everybody thought it was manageable as well. All right, let's continue. We move in, we're doing exam past papers. This was January. Why is this important? Most times the June exam mimics or is very similar to the January exam, but just higher difficulty. So it is important that you are able to answer this question so that you can work from there. All right, next one. The bowl is completely filled with soup. When all the soup is poured into the cylindrical can, oh my God. Let's go again. The bowl is completely filled with soup. Lord help me. I like drawings, eh? So I like to draw. So the bowl full of a soup. All this is soup. Okay. Okay. They say when all the soup is poured into the cylindrical can, so I'm going to draw my can. And I can just put an arrow saying when all of this turn over here, 90% of the volume of the tin is filled. So I'm just going to draw a line and I'm going to put 90% in here. Everybody following? Calculate the radius of the bowl. So let's work that out now. Let's look at this working. Let me see if I like how they work out this first and then go from there. Because if I don't like it, I'll do it my way. So let's follow. First thing first, volume of a sphere. You must have the volume of a sphere. Because first thing first, the soup bowl is half of that. Everybody agree? So this is a sphere is a complete round circle ball. The ball is half of that. So the first thing we got to do is find the volume of the entire sphere and then half it. Let's make sure everybody understand that. If you got that, you got it. So step one, find out how much soup in the bowl. To find out how much soup in the bowl, you got to find out what shape the bowl is. The bowl is half of a sphere. So you got to find the volume of half of a sphere. So this is the volume of the sphere. So all you gotta do is find half of it, right? Volume of Super Bowl is this, half of this. So let's come down here. What do you notice about this? Sorry, I don't know why this is doing that. What do you notice about this? This ain't a substitution question. When you plug it in, you realize you don't have R in it. I made a mistake earlier by assuming that the R's are the same. That's not what I meant. I meant that R for the cylinder is 6 only because 12 divided by 2 is 6. So let's get back here. So what they're saying is use the information that you have to find the information you need. You know two things, that the soup is going to be 90% of the cylinder, and we know how much the cylinder is. So let's go from here. Let's go here. I want to do this different because this is a little confusing. Before I explain, anybody understand what it's trying to say? Read it and tell me if you understand it before I explain. This is what I want you to practice doing, reading comprehension. All you need to say is yes or no. You understand what it's saying, or no, you don't understand what it's saying. Okay, that's fine. That's why we're here, right? So let's go, guys. Lock in. What they're saying is, I would have done this differently. What I would have said is that, you see how my drawing is? I know that this entire thing, we ain't calculate that part already. We ain't calculate how much this cylinder is. The entire cylinder is 1923. Everybody agree with that? We also know that the volume that could fit inside of the bowl is 90% of that. So what I would have done first is find 90% of the cylinder. Wouldn't that make sense? Because what information that gives me? Doesn't that give me how much volume is in the bowl? So we get closer to finding out what the radius of the bowl is. If you see what I'm saying, you cannot calculate the radius of the bowl without knowing any information about the bowl at all. They gave us information about the bowl when they said that 90% of the tin is filled from the soup that was in the bowl. So I would go ahead and find 90% of that volume. And why would that make sense? Didn't we literally calculate the cylinder volume already? So we have that information. So it's almost like the question we did before gives me an idea of where to start for the next question that comes after. So I would find 90% of 1923. Somebody with a calculator, let's go. 90 over 100 times 1923. Calculators, how do we do this? 90 divided by 100 times 1923. Tell me where you get. I hope people using the calculators, and because This is what we're supposed to be doing now. This is probably the most important thing that we're going to be doing right now. It's important for you to be able to calculate it and get an answer on your calculator. So I'm seeing 1730. Okay, let's see if that's what they got to. They didn't even work it out. So I can just trust all you. I can trust y'all, okay? That's a big move, eh? 1730. And what does this number represent now? This number represents the volume of the bowl. So everybody agree with that, right? Now, what other piece of information we have? We should know the bowl is half of a sphere. Don't we know the volume of a sphere based on the formula? So this number 1730 is the same thing as finding half of this formula. Everybody see what's going on now? Everybody understand why these two things match up? Let's start here. That's all I want to know. Yes, it should round off to 3-1, to be honest. I was watching that too, but you are trying to figure out how to teach this thing here. They didn't even study that. So let's just round it off one time for reals. So talk to me, guys. Talk to me. Everybody understand why these two things are equal? This is the actual number for the volume of the bowl without the units. Sorry, I should have put the units. What the units was? Meters, centimeters cube. What was the units? Centimeters cube. Look, the formula here, Janesco. I gave her the formula of the volume of a sphere. That's the formula for how to find the volume of a sphere. See it now? So let's pause right here. Let's pause it right here. Everybody with me so far? Let's move this here. What is this number? This number is the volume of the bowl. And over here is just the formula for it. Yes, no problem. Everybody realize what's going on? I just took the formula and put it equal to the answer. Anybody have an idea what we should do next? If I want to find R, shouldn't we just transpose now? You realize that's all going on now, right? All you expect it to do now is transpose. And what are we transposing for? We ain't transposing to find R. Because what did the question ask us in the beginning? Calculate the radius. So let's pause here. Everybody see why we're doing what we're doing now? You're taking the information that you find to use it to find what they ask you for. So let me see how they work it out. Everybody realize that's all they did? And when they finish, they transpose. And that's how they find the answer. So tell me if you want me to work it out all the way. Because you know, me gonna work it out like this. Y'all know I is not going to work it out like this. I will not work it out like that. Like, as in, like, you see how they got it here? I ain't working it out like this. I'm working it out how we did it. So let me screenshot this here and work it out for you guys. Where did this go? Hi. Any questions? Yeah, ask a question, folks. Hold on, I'm trying to find where the question gone. Where did it go? Here it is. Okay, no problem. All right, let's look at this. Now, what is this? What brackets mean? What does brackets mean? So I can put back this 1731 centimeters cube. What does brackets mean? To multiply, right? So all I gotta do, because this is one thing. This is not more than one thing, it's one thing. So all I gotta do is multiply the two coefficients are the two numbers. So 1 times 4. So this is equal because you bring on the equal sign. So 1 times 4 is 4. 2 times 3 is 6. So this would give me pi r square. Cube, sorry, cube. Okay. Because we want r, what all need to disappear first? All of this ain't got to disappear first. The pi and the 4/66. Everybody with me? And remember, they tell us to use 22/7. So let's use what they tell us must use. So let's put back that. So this is going to give me 4, 6. Remember, all of this is times as well. Times is everything happening in between. So that's going to be times pi, which is 22/7, equal, no, times, sorry, r cube. So you put back 7. I need people with the calculators on standby. Let's go. 4 times 22 is 88. 6 times 7 is 42. 42 r cube. Okay, how do I get rid of this now? The first thing I would do is get rid of the denominator. This means divided by 42. So what would I do? I would multiply by 42 on both sides, right? Because what does that do? That gets rid of divided by 42. So somebody tell me, what am I going to end up with? I'm going to end up with 88 r cube is equal to 1731 times 42. Calculator people, let's go. 88 r cube is equal to what? What is this, the answer when you multiply these two things? Thank you. 72702. I just need one more person to confirm. Excellent. What do I do next now to get closer to the R? How do I get rid of 88? I just need at least one person to tell me so that we all on the same page. Excellent. We divide. Very good. You divide on both sides. Divide on both sides. So people, calculator people. So R to the third power is equal to what answer? Make sure you're working your calculator. Make sure you're getting it. 826.1. Let me just go and check to make sure we're on the right track. See? 826. Guys, look at us. Guys. Guys, cookies for everybody. Very good. And everybody understand what I've been doing each step, right? Just to make sure it's like you following the... No, I was just excited. Yeah. But everybody following how we got through here? Okay. No, this is the part that's a little different. The power is cube. Look on your calculator for this thing here. You're either going to see 3. Some people come with the 3, which is, remember, the opposite of cube is cube root. Some people got this here. Look for it, please. Some people got to type in 3 and then shift and then press that button here to get this. Tell me if you find it on your calculator. So tell me if you can work it out. So cube root, both sides. Cube root, both sides. But that's the only way to cancel a cube. So you end up with cancel each other. So R is equal to the cube root of 826. And tell me what you get. Everybody, I need to see what your calculator is saying. We're actually doing really good on time as well, because the fact that we actually make it to it could never be 9. You know why it can't be? Okay, maybe it could be 9, because 9 times 9 is 81, and 81 times 9, that should be right. Yeah, that means I am not cube rooting. Cube root, you should get 9 point something for true. Check it again. You're supposed to get, let's check what the answer is. 9.38. Sorry. I'm so sorry, guys. I just get so excited that y'all were able to calculate it and get the answer. With my steps, of course. But so those who got 86.22, try it again and tell me if you get the 9.38. This is a calculator thing now, eh? This is a calculator thing. We got to make sure you know how to use the calculator to do it. All right, where my thing gone? Guys, where did it go? On my work, where did it go? Kamai and Pinky, did you get it? Let me know, please. So the answer is 9.38. And what does this represent again? This is the radius, right? That's the radius. So that's it. That's done. Let's move on. Okay, before we move on, how y'all think that one was? Hard or it wasn't so bad? It wasn't so bad. Talk to me, talk to me, talk to me. That's the first CXC question that we did. To me, it easier than the questions that we was doing with me, to be honest. Okay, that's what I like to see, that the questions don't seem as intimidating as before, and that y'all could at least manage handling it as much as possible. Okay, so let's bust through the second part. Let me see how much parts this got. Okay, so it's just an A and a B. It's just an A and a B. So we finish A, let's do B. In the diagram below, what does it look like to you? What y'all noticing going on here? That there's a shaded area in it with a semicircle in it. And then what else you realizing you're seeing the 90 degrees, like similar to the one we did before. Remember, I tell a lot of the questions just variations of each other. So that means we should be able to handle it. So let's go. In the diagram below, points L, M, N are on the circumference of a semicircle, which we already see and identify because this here, LN would be the diameter. Agreed? ON and OL would be our radius. They say that the radius is 18 centimeters. So what you should do, grab your pencil, put 18 here. Well, first of all, this is what I would do. I'm going to be honest with you. This is what I would do. I know that this line is the diameter. So I know this from here to here. I would take my pencil and draw across and put 36 here. And then I would use this line because this is also a radius, right? And put 18 here. Everybody see what I just did? Oh, man, they do the same thing below. I just watched down and I realized, man, if they put the 36, but I would have add 36. I'll put 18 and 18 over here. Always use your diagrams. Always use your diagrams. All right, let's go. It says, calculate the total area of the shaded sections. Everybody see what I was saying was the truth? That the same things just come back just in different ways. So look at the next part now. Find shaded area. So we know already what gotta happen. We know we gotta find the area of the overall semicircle. Agreed? Hello? Hello? And then we know we gotta find the area of this part, the white part. And then what we gonna do with both of them, peoples? What are we gonna do with both of them? That's the key part. What do we do when we find the big shape and then we find the small shape? What do we do with both of them? Excellent. We subtract. Excellent. No, you think there's a reason why? Don't you realize that there's a reason why they gave us this line in the center? Do you realize that they could have just made this one triangle? But do you notice that there's a reason why they gave us this line in the center? What shape is that? What shape is this here? Everybody see that? And it's an isosceles triangle, by the way. Eh? So let me see what approach, because I have my own approach that I would take, to be honest with you. I have my own approach, but let's see what approach CXC took. In my mind, I am looking at the fact that I have a shape, which is a triangle, right? And I could find the area of this triangle easy. Why is it easy to find the area of this triangle? The area of this triangle is a right angle triangle. This in the height, 18 in the height. So, to be honest, once you find the area of this triangle, isn't it the same thing as this triangle here? Aren't these triangles twins? If you look at it. So, I could use which formula, because we did 3 formulas yesterday, half base times height. Everybody with me? So, that would be half of the base, which is 18, times the height, which is 18. So everybody see that's how they found the area of one of the triangles? Talk to me. No, this is the approach CXC took. Yeah, remember last night we did the sector version where you find the area of the entire sector and then you find the area of the triangle and you subtract it and then they would multiply by 2. Look at it. That's what they used. So they found area of the sector, area of the triangle, and they subtract it, but that's not the answer because it got 2 sides and then they would have had to multiply by 2, right? Anybody, which one look easier to you though? I would have gone and find the area of the overall semicircle, multiply the triangle by 2, and just subtract it. Me know why they're going to make this thing hard for. This thing got to be so hard. Why they going to use the harder version? So let me do the easy version, please. Let's do the easy version, and we're going to get the same answer. All right, what happened there? You see, the thing like you're trying to warn me? Okay, so let's go. Let's find the area of the semicircle. We know a semicircle is half, right? So it's going to be half. And what is the formula for the area of a circle? Pi r square. So calculators, please. I need all your calculators. What is pi is 3.142. And the radius is 18 square. So you find it, you don't take this in just so, find the area first and then half it. And when I mean half it, divide by 2. So let's go. Half of the area, what is the area? 3.142 times 18 times 18. Everybody, calculators in hand. Everybody's supposed to be typing and posting the answer. Look at this, but quarter of a, all this drama is unnecessary. We're just doing it an easier way, a way that makes sense for us because we know the bigger shape is a semicircle. We just gotta find the area of the 2 smaller triangles and then subtract it. So somebody said 10, 18. Anybody else? Anybody else? Anybody else? Oh, look at here, the alternate method. Area of the semicircle minus the area of the triangle. Yep. Anybody else got 10, 18? Come on. What is 3.142 times 18 times 18? Excellent. So we have here 10, 18, and then half of 10, 18. I could have this easy. That's supposed to be 509 because half of 10 is 5, half of 18 is 9. 509. So that means that the area of the thing is 509. Okay, so let's come down here. I just realized they have it here. Watch, compare this. Watch all the steps to this step here. That's what they were supposed to do in the first place. Half of pi r square, which is this, 509, right? Minus the formula for the area of the triangle. So let's go back up. Let's go back up. Sorry. How to go back up, guys? How do I go back up? Oh, that's what we was doing before, innit? So we know the volume of this one triangle. How much will you get again? How much will you get when we find the volume of this, the area of this triangle, which was again, sorry, I forgot. Half base times height. Half base times height, which was half of 18 times 18. So that would be 9 times 18, which would be what? 162? No, that's right. Wow, it's impressive. Centimeter square. What did I just find? Didn't I just find the area of one of the triangles? But how many triangles are there? It's two of them in it. So we times 2. So that would give us what? 324. So everybody realize the two numbers that we have now? This number represents the semicircle, which is the bigger shape. And this number represents the white triangle. So how do we always find the shaded area? We subtract the bigger shape minus the smaller shape. Let's go down and see if we're on the right track. Excellent, 324. So our answer is this. This was an easy question. Everybody with me? Everybody understand this one? This was an easy question. I hope a question like this come for you. If you got it, say got it. Talk to me. I think it was a really good idea that I did all of the harder questions first, so that when we got to these questions, it's a lot easier to understand. So I think that was a really great approach that we took. All right, so what time it is? What time it is? We're only going up until 7. We're not gonna answer the question. We're just gonna look at how the question come, right? All we're doing is reading through together. All we're doing is reading through June 2023 together. We're not gonna answer it. We're just gonna make sure we understand to see if it's familiar based on the patterns. Okay, let's go. When do a shape question just like that? Are you? This is becoming. What is that? Hold on. Oh, we did it already too, somewhere else. Hold on. This ain't what we did there. The perimeter, how to find, remember we explained how to find the perimeter? You find the curve, the area, and the two radius. Peoples, anybody seeing that? So you see everything we did coming back when we did the angle and you got to put that over 360, wap, wap, wap. They said find the perimeter of the sector. We literally did the perimeter of a sector already. So what, just to quickly do it, may not do it all the way, but you know, this is 12 because this is the radius, right? And then you know how to find the length of the arc, which would be 168 over 360 times the area of the shape or the circumference. I just want to make sure me crazy. Yeah, remember that, right? I see Rod said yes, Denaya said yes. Anybody else remember it? Actually, as soon as I come off class, me and upload it to YouTube, to be honest, because after class, I was so mentally tired. So I have to upload last night class to YouTube and tonight's class on YouTube, and I'm going to do that as soon as we finish. So all we're doing is reading through. What would be the next question? What is this? A cone. Find the radius of a cone. Everybody see what's going on here? Let's look at the next, just peep at the next question, number 6, and that's it for tonight. Quick question. Tomorrow is Wednesday. The plan for tomorrow is to go through the entire January paper from front to back. So we have two options. We could do more, some question 6, if you think we should do more question 6, or we could go through the entire January paper. Which one y'all think? Because I feel like y'all should be able to handle reading through the questions then by yourself now, to be honest. I gave everybody this website. So I think that we really should go through the entire January paper. So that's one person vote for January. Come on, talk to me, everybody else. Because I need to know that when you go into the exam that nothing, if something came from January, I could say for sure I know we cover it. For reals. So tomorrow class, okay, so I am going to do an extra session on Saturday. I don't think I'm working on Saturday. Let me check. I might do a session on Saturday. Let me see. Oh boy, Saturday is bad. I have a face painting job on Saturday. So the only time I'm free on Saturday, but I'm free on Sunday morning. I'm free on Sunday morning. So I could do earlier in the day on Sunday. So if anybody free anytime on Sunday, we're gonna have Sunday in the night, 6 to 8 again. But I wanna, if anybody wanna do a extra session in the day, you can message me and I could send out a message and say, okay, guys, I'm meeting with some students at this time. You could join if you like. So we could confirm a time closer. So that's what we're gonna do tomorrow, guys. That's it for tonight's class. I hope tonight was helpful. I see some improvements. So good job. See you guys tomorrow. And I'm going to upload the videos now. If y'all don't see it, just message me and remind me. Bye.